propagation of electromagnetic waves. So these electromagnetic waves are employed and used in communication system like radio, TV, cell phone. And these electromagnetic waves, we call them EM waves. They are radiated from transmitting antenna. So they are radiated like this from transmitting antenna in all the direction of the space with speed of light. The antenna can be unidirectional, it can be omnidirectional. Omnidirectional means the propagation will be in all the direction. The Earth atmosphere also plays a very important and vital role in the propagation of waves. So there are different ways by which this electromagnetic EM waves emitted by a transmitting antenna like this propagate through space, and it actually reaches the receiver here. So the waves propagating along the surface of the Earth, if this is the Earth, and the wave which are propagating along the surface of the Earth, these are called as surface waves or ground waves. The waves from the transmitting antenna reaching a receiver in a single line or after reflection from the ground, these are known as space waves. Then we have sky waves. The wave which is reaching the receiver at a large distance from the transmitter, means say from here to here, it's a large distance. After reflecting from a layer of the Earth atmosphere like ionosphere from 60 km to 300 km from the surface of the Earth, so it is reflecting from the one of the layer and it's coming back, and these are known as sky waves. So ground waves, space waves and sky waves. The conductivity, the permittivity, the permeability and the refractive index of the medium all play a very important role in the propagation of waves like ground, space and sky waves. Ground wave propagation or surface wave propagation. So in this ground wave propagation, the EM waves, they propagate along the surface of the Earth. So if this is surface of the Earth, it goes like this along the surface of the Earth. So due to different electric properties of the Earth and the atmosphere, these waves from the transmitter follow a curved surface of the Earth and reach the receiver. So ground wave propagation is possible if the transmitter and receiver, they both are close to the Earth's surface. And because of the electric field of the ground waves, the electric charge is induced on the surface of the Earth. Say, let me take the ground like this. So if the wave is traveling like this, there is a charge being induced here, right? If this is positive, this is negative, and this is negative, this will be all positive. So there is a charge being induced during the wave propagation. So this charge is also moving. It also produces an electric current. And what fact we know is the conductivity of Earth is not finite. That is, the surface is sandy at some place, there may be boulders somewhere, there may be stones, there may be trees. So the surface wave propagate due to different medium of different but certain finite conductivities. There are different conductivities because of the sand, because of the boulders and other Earth surface material. So the energy of the wave goes on decreasing due to this finite conductivity. Since there is a charge being induced at the Earth's surface because of this wave, and also because of the various different element of objects conductivity, the energy of the wave from transmitter to receiver, the energy is diminished or it is decreased. Along with this, the intensity of the electric field of the wave is inversely proportional to the distance from the sources. So the absorption of the energy of wave also depends on what frequency, or what is the frequency of the wave. So absorption of energy is more if the frequency is high. If it is higher, the higher the frequency, there will be more absorption of energy. Therefore, the waves with frequency 2 megahertz or more, they don't propagate to long distance via surface waves. That is why if after this value, there is no point in sending the wave of higher frequency, because of these reason, all these reasons, it is not going to propagate. So the waves in medium wave band, that is from 550 kilohertz to 1600 kilohertz of AM radio, they propagate through the ground waves. This is just an example.